Hello, and welcome back to another episode of Low Spec Labs. Before we get started, I would like to stop and say thank you. Thank you for tuning in, thank you for commenting, and thank you for subscribing. If you're new to the channel and you like what you see, please go ahead and subscribe. Otherwise, let's get started with chapter 25 of the RHCSA EX200. This is about NTP, or Network Time Protocol. Before we dive deeper into this chapter, let's discuss the various different times or terms for times we'll be using. The first is your hardware clock. This is a clock that is built into the circuitry of your motherboard, and it's what the server or computer uses to keep track of your time. Next is the real-time clock, which is just another name for your hardware clock. After that, we have system time. That is the time maintained by your operating system. That is different from the hardware clock. After that, we have the software clock, which is another name for system time. Another term you're going to need to know is Coordinated Universal Time, or UTC. This is a worldwide standard time. Of course, after that, we're going to talk about Daylight Savings Time, which I assume you know what Daylight Savings is, so we'll skip that. And last but not least is your local time, which is the current time in the time zone that you reside. Why is the time on your network so important? Well, a lot of things on your system relies upon accurate time. This includes your logs, your SSL certs, your authentication. All of these require that the time on your systems be accurate. There are two ways to guarantee the accuracy of the time on your system. The first is getting a very accurate hardware clock and plugging it into your computer. And the second is using NTP. We're not going to cover hardware clocks today, but I will pop one on screen for you. It should be right there or to the bottom. And now we can start talking about NTP. NTP is otherwise known as Network Time Protocol. It is a protocol developed to synchronize times of computers over a network. NTP works off of a client-server model. So normally there's one or two NTPs somewhere on your network, and all the devices on your network point to that server and get their time from there. That server gets its time from an authoritative NTP server, which is somewhere on the internet. How do these servers on your network know which NTP server to connect to? Well, part of the NTP protocol is something called stratum. And what stratum is a way to define the priority of an NTP server. So the lower the stratum, the more important that NTP server is. Stratums range between 1 and 15, with 1 being the highest priority and 15 basically telling all NTP servers to not use that server. So that's all the theory you kind of need to know about Network Time Protocol. Let's walk through actually managing Network Time Protocol. When managing Network Time Protocol, the first thing you'll need to know is how to get the system's current date. How do you do that? Well, the date command is very useful for that. I've already logged into my server. Using the date command is very straightforward. To get the current date, we simply type in date. As you can see, it shows the current time, which is Friday at 1:20:36 p.m. The date command can also be used to show the month and year that you're in. How do we do that? Well, it's pretty straightforward. We do date plus, and then we're going to use the parentheses to define the format. So we're going to do month, percentage, day, percentage, year. As you can see, it's 7/6/24. We can also use the date command to set our time. How do we do that? We'll use the -s flag. So we'll do date -s 16:03. You can see the date is now set to 4:03 p.m. Eastern Standard Time. Of course, I'm going to change that back to the proper time. And there we go. It's now set back to 1:34. So the date command sets your software clock, but it does not change your hardware clock. How do we change the hardware clock on our system? Thankfully, there is a command for that. That command, it's HW clock. One thing you might want to do is synchronize system time to the hardware clock. How do we do that? We use HW clock --sys2hc. And now if we were to run date, you see the time is set to 1:43:55. So we've reset the software clock to match the hardware clock. What is time date CPL? Time date CPL is a utility included with systemd that lets us manage time. So we can use the date command to set our time. We can use the HW clock command to set our time, or we can use time date CPL to set our time. The benefit of time date CPL compared to something like date or hardware clock is that time date CPL lets you set time via NTP. When you use time date CPL, it's technically using the Chrony D service to set your system time using NTP. We've got our terminal pulled up here. Let's learn how to use time date CPL. Before messing with your system time, you'll probably want to get some information about it. We can use time date CPL to do that. So time date CTL status. As you can see, it gives you a printout of the different things that are going on with the time on your system. You can see NTP is active. It gives us a time zone. It gives us our local time, our universal time, and then our RTC. We can also use time date CTL to view our time zones. It's pretty simple to do that. We do time date CTL, list time zones. As you can see, it shows us all the available time zones we can swap into. This is necessary because if you want to change your time zone, you kind of want to know the format to put it in. How do we set time zones with time date CTL? Well, that's pretty straightforward. We can do time date CTL, set time zone, right? And then we set it to one of the time zones that were listed with the list command. We could do something like Europe, Amsterdam. And now when we type in date, you'll see our date changed and it's CST instead of EST. What if we wanted to change it back? We could do time date CTL set time zone America and then New York. Now when we run date, you can see the date has changed again right here. Time date CTL is not the only command we can use to set our time zone. Let's go over that real quick. If we were to do TZ select, if we were to use the command TZ select, we get a much more convenient way for us to set our time zone. So in this case, we're going to set our time zone to Americas, and then we're going to set it to Mexico, and then we're going to send it to Central Mexico, and then we're going to confirm. We press 1 to confirm, and there we go. Now when we type in date, you'll see our time zone has changed by a couple of minutes right here to 24:32 a.m. in Mexico City right now. We can also use time date CTL to set the time. Before we do that though, we have to have the Chrony service running. So let's verify Chrony D is running. And there we go. As you can see, Chrony D is running, and it even lists us the servers it's using to get its time right here. As you can see, the first couple are offline, but the last few are online. So we know Chrony D is running. Next, let's turn this into an NTP server. To do that, we do time date CTL set NTP, and then we choose 1. And there we go. Now this server is a NTP server. We're almost done setting this server up as an NTP server. The next thing we're going to have to do is edit chrony.conf. So we do nano etc chrony.conf. And then what we want to do is scroll down to the section that says allow and uncomment this line. Make sure that the network that's listed here is the appropriate network. In my case, my network ends in 2.0, so it is allow 192.168.2.0. We then have to add the firewall rules to the NTP server to allow clients to access it. So we do firewall cmd, that's add service, equals NTP, that's permanent. And there we go. Then we have to reload the firewall, and that's it. The NTP server is now configured. If you recall from a few minutes ago, NTP is a server client-based protocol. So we've set NTP on a server. Now we have to log in and set NTP on the client. Let's do that. In order to configure NTP on a NTP client, you have to configure file. That file, it's etc chrony.conf. We're almost done with this chapter, so let's go ahead and configure that. And that's it, boys. We're done with chapter 25. So let's do nano etc chrony.conf. All right, so we now have our NTP configuration file opened up. Let's take a look. So enabling NTP on the client is as simple as changing one line. Let's go ahead and do that. If we were to scroll to the top of our config here, you see the line that says pool, and then it gives us a DNS name. What we can do is comment this out and then do pool, and then we just simply type in the IP address of our server, and that's it. We hit save, and then we restart cronny D. Then of course we check the status, and there we go. That's it. Now all the servers on our network will get their cronny config from that specific NTP server we just set up. Before we head out, I'd like to say thank you for giving me about 10 to 15 minutes of your time. I hope you enjoy this content. If you have any questions, please feel free to leave them down below, and I'll do my best to answer them. Otherwise, look forward to chapter 26, and then we are done. That one is about containers, and it is a very thick chapter. So the next video is going to be a little longer.